questions. But for everybody else, if you have questions, just please pop them into the chat, and we'll do a Q&A towards the end. But yeah, Wyatt, Butter, please take it away.
Sure. Awesome. Yeah, well, thanks so much. My name is Wyatt Slifkek. I'm a senior, 4th year here at Case Western. I'm a mechanical engineer, and I'm currently here on the 2nd floor of ThinkBox in one of our nice conference rooms. And today, myself and Butter are going to give you a quick tour of the space and show you around a couple of products that we have. So with that, Butter can go ahead and introduce himself.
Hello, everybody. My name is Badr Jahangir Kiani. I'm also a senior here at Case, finishing my master's. I worked at ThinkBox as a student technician for 3 years now. So I have a lot of experience and knowledge about what goes around here. I've done various projects, some of them which I'll be showing you around. So this, like Wyatt mentioned, we'll be showing you around the 2 main floors and showing you some of the projects. So if Wyatt can introduce the space a little, I can then after that get started with showing you around on the prototyping floor.
Sure, no problem. So yeah, I'm down here on the 2nd floor, which is just our general project space, where people can collaborate and things like that. But Butter's now up on the 3rd floor, which is our prototyping floor. So that's the 3rd out of 7 total floors in ThinkBox. We have a very large open access facility here. And the prototyping floor is essentially where we house a lot of our machinery that's geared towards making prototypes quickly, like 3D printers, laser cutters, things of that nature. So Butter's going to go ahead and show us around, talk a little bit about each machine. All the info can be found on our website. I'll post a link in the chat in a second. But if you do have any questions, please feel free to reach out through the Q&A section, and myself or Butter can get those answered for you. So yeah, go ahead, take it away.
Sounds good. So as Wyatt mentioned, we're on the 3rd floor. So we'll first get started with a general quick walkthrough of the floor. There are a lot of machines and a lot of equipment here. So we won't go into a lot of detail about what each of the equipment does, but we'll do a quick walkthrough just to give you an idea of what we have, and then we'll talk about some of the projects. So as we enter, as I was showing, this is like our front desk. So our student technicians are at this desk, and anything you want, you can approach the desk and ask for that. Right beside it, we have our 3D scanner. This is a scanning arm that can scan 3-dimensional objects for recreation, historic preservation, stuff like that. Right here, we have a plethora of desktop 3D printers. These are Ultimaker 2 Pluses. They quickly prototype your designs and print 3D models in plastic material on a relatively cheap basis using cheap PLA filament. These generally are self-serve machines, but because of COVID, they're also a service. So just as an FYI, this is our project shelf for the 3rd floor. We will come back to that. There's quite a lot to be said about that. Here we have our workstations. So our workstations are fully loaded with all of the software that you would need for your design work. So for CAD modeling, 3D design, 2D design. So we have like CorelDRAW, Illustrator, SolidWorks, so on and so forth. Like anything you would need to design projects or design things for to use on the machines, our workstations will have that. Moving towards the right side, we have our media center. So our media center has a vinyl cutter. This can be used to cut stickers, put on like cars and Baja vehicles and motorcycles, so on and so forth, or laptops for that matter. You will notice we have a lot of variety of colors, so you can choose for the color you want. Over here, we have some other, so we have our sewing machine. This is a digital sewing machine, so it's very good and it can do quite a lot of advanced stitch patterns. We have our 8-thread embroidery machine, which can embroider like towels, scarves, hats, t-shirts, stuff like that. It is also fully digital and it is industrial grade. So this is the electronics section. We have our PCB router. The idea with that is that you submit your PCB files to get circuit boards prototyped very quickly. So this will be an example of like one of the circuit boards that you can get. We also have electronic workstations. So these workstations have soldering irons, hot air workstations, so like computer monitors. And then we also have microscopes. So this is a 2D microscope, digital microscope. And then we also have a 3D microscope that is used for to work with small circuits and small components, just because some of those are very tiny, so you can't easily work with them just by looking at them. So these will magnify them and make it easy to solder and rework different circuit boards. We also have some electronic parts that you would need for assembly purposes. So moving on to, so now we'll move on to our additive manufacturing studio. So the additive manufacturing studio is essentially a service that that ThinkBox offers. The idea behind the additive manufacturing studio is that you can, once you're done with the prototype, you can get the parts printed in these machines, and these will print in much more robust and resilient materials. So they'll print in polycarbonate and ABS. So you can see we have the Stratasys F123 series printers. So we have 3 of them. We have the Fortis 400. And then this is our recent addition. It's the Stratasys J750. This is a resin-based printer, which can print in full color. So this over here, you can see some of the examples of what I'm talking about. So all of these are printed with the resin-based printer. So you can see you can get like colorful models like this. You can get like squishy models as well, full color models and like very fine detail. So with these printers, you won't see the print lines or anything like that. Like they'll be much finer resolution. And with the FDM, since the technology is still choose deposition modeling, you can see the print lines, but you can do a lot of complex geometry. So, like parts like these, you can also do flexible parts and like, very robust and strong parts that you can use in your functional prototypes. So these printers are good for that. Like I mentioned, this is a service. So you'll submit your parts online and our student technicians will help you, will process the parts for you. And then you can come and pick them up. So moving outside of the additive manufacturing studio, we have our photo booth. So we have our photo backdrop. So as different colors of backdrop, so you can use this area to take photographs of bigger projects or take portraits of yourself. So a lot of people take LinkedIn pictures here. We have like camera, like a high quality camera and lights. They will lead to like their professional grade equipment, and that will lead to very high quality photographs. We also have a photo table. So for smaller projects, you can just put them on the table and take the picture there. So moving on, we have our laser cutters. These are our most used machines in the building. They are Fusion Pro 48. So they have a big work area. As you can see, the work area is 3 foot by 4 foot. So like large workspace, and they're 120 watt lasers. Essentially what all of those numbers mean is that you can laser cut big things and thicker materials quite easily. Some people are working on these, so they are a little bit loud, so we won't get close to them, but you can see that they have their material loaded in there, and then a laser will essentially cut that material to whatever shape and size they want. So you can design your file like on the computer and then cut it out of a variety of materials, including acrylic, wood, leather, so cork, so on and so forth. So you can use a variety of materials. Over here, we have our dirty room. It's being heavily used right now for an experiment. The idea with the dirty room is that you can do like stuff that will produce a mess. So essentially, something that will produce a mess will be done here in the dirty room. So like gluing, find a little bit of sanding here and there. It's not meant for painting. Painting, we have a separate paint room for that. But anything other than that, for like gluing, sanding, finishing work, we also have a vacuum chamber. So if you want to do like epoxy pours, like if you see on YouTube, there are a lot of videos about like, epoxy tables or like small epoxy resin, like jewelry and stuff like that. You need like a vacuum for that. And we have that. So it can pull out all the bubbles from the epoxy resin and give you a very fine mold. And then we also have electronics recycling. So that's a very quick overview. I know we have a lot of machines. I would like to iterate that we do have all of the information and services is on our website. So if it feels like this is overwhelming, you can just go and look through the website to see some of the services that we offer. Now, and if you also want, I'm sure Wyatt will put the link in the chat, but we do have like a full detailed tour that is recorded and on our Facebook page. So you can go and look through that if you do want more of a guided tour through the space. But for this tour, what I would want to focus on is more of the projects that we have built at ThinkBox using ThinkBox resources. And the idea being behind them is that you can maybe get some inspiration and find something that maybe you would want to try to replicate at ThinkBox. So it'll give you a reason to come in, and maybe if you don't have an idea, you can use some of these as examples. So we'll look a little bit closer at some of these projects. So if you look at it from top, you can see a lot of these are 3D printed. So some of these bones, these skulls are 3D printed using the polyjet machine. So you can see very fine surface finish with a lot of colors and stuff like that in there. We can print some bones. A lot of because we are closer with the medical school, we do a lot of collaboration with them on these different like bones and skulls and stuff. But you can also print some interesting things like I printed this torsion gear differential system as like a model, you know, so you can like print this and play around with it. So like this entire thing is printed on our 3D on our desktop 3D printers. This vase was also 3D printed. And then this globe was laser cut actually, and it has 3D printed parts inside. So you can make this potentially if you want. You can even customize it and put your own logo or your own design on it on the laser cutters. You can see this is an RC car. It's fully 3D printed and laser cut. So like the top portion is laser cut. All of these parts are 3D printed. You can see this is 3D printed in a flexible material. The wheels are also flexible. So with the technology that we have here, you can make something like this. This is more of a model, but this can be a functional car as well. And these are like the design files for these can be found online. So if you're interested in making your own RC car, I know as a kid, I always wanted to make my own RC car. So this is a good project for somebody who's looking to achieve that goal. And because of all of the equipment and like materials available at ThinkBox, you can make that very, very easily and learn a lot in the process. Some of these other projects, this is an Rgb lamp that I built. I won't go into too much into the technical details, but it's controlled by your smartphone and you can control the animations and the colors, and it can react to different things. So for example, if you get like a Facebook notification, it can blink and stuff like that. So it's like whatever you want to program into it, it's connected to the internet. So you can program that in. This is a small robotic arm that I built. So I'll do a quick demo here. Oops, sorry, let me get it in frame. You can see, again, something like this. This is something I found the design online. So if you want to make it and make it one for yourself, you can definitely do that. It only has a very primitive program that does as what you can see, but you can essentially program it to do whatever you want. Maybe, you want to program it to do some special task or like maybe paint or draw or something like that. You can do that with this one. So these are, I'll talk about these. So these are some of my own personal projects. So this is a robot that I'm building. This will be a fully autonomous robot, which means that it will drive itself. Right now it doesn't drive itself. Right now, hold the e-stop. Right now I have to drive it manually, but the whole idea is that it has like all of these sensors. Oh, sorry. Oh, my bad. So you can see it has all of these sensors. So like 1, 2, and 3. So they have cameras, distance sensors, GPS. So it can see and sense its environment, and then it can like drive around outside and inside. So you can see it's doing its thing. So this is another project that I built. It's an autonomous race car. So you can see it has a camera in the front, and inside it has a lot of electronics. So we can quickly open it up and see what we have inside. So you can see it has a computer on board. It has a wireless connection, so it's connected to the internet, and it has a camera, so you can control it wirelessly, and you can program it to follow any path that you want. So right now it is also in like remote control mode. So there it goes. But you can make it drive around like that fast autonomously. So that's the goal with this project. Again, something that I've been building using ThinkBox resources. So you'll notice that the entire top part, like this part, is 3D printed, and like all of these inner parts are also 3D printed and designed. So all of these like projects I've designed using ThinkBox resources. So like CAD, so like SolidWorks, and laser cut. So you can see this one like is entirely built out of laser cut material, and that was laser cut on the laser cutters and stuff like that. So the idea is that you can, while some of these projects may look very complex, and they are quite complicated. The idea is that you start from something simple. So like even when I first came, I started with something as simple as this, or like as like a vase, just 3D printing, or we also have like cookie cutters, Spartan case cookie cutters, something very simple that we can, we can make to kind of get our hands dirty on the machines, and that will lead us to eventually making, like putting all of those skills together and making something as complicated as like a autonomous robot or autonomous race car and stuff like that. So do we have any questions about these projects that we can talk about real quick, or should we move on to the next floor?
Great. Yeah, so thanks, Butter. Anybody have any questions about any of those robots or any of the 3D printers, laser cutters, anything we talked about? You can go ahead and post those in the chat. We can answer those at any time. Yeah, if you're interested in more about those machines, you can check on our website. But we're going to go ahead and move up to the next floor on our journey upwards. So Butter's going to go ahead and head up there, and I'll give you a little spiel about the fourth floor. So the fourth floor is our fabrication floor. And the way that it mostly differs from the third floor is that the fourth floor houses more heavy duty equipment for manufacturing, actual final products and more heavy duty prototypes and things like that. So while the prototyping floor is really good for manufacturing small things that are really easy to make and prototyping, iterating very quickly, the fabrication floor allows you to work with tougher materials like metal and wood and things of that nature to get your projects done. So on the fourth floor, we have a full metal shop and wood shop. So we have all the tools that you'll ever need to work with any of those materials, as well as a full welding studio. So you can come in and learn how to weld up your projects, so you can do it on your own. So one of the other differences between the fourth floor and the third floor is that on the fourth floor, when you're using it, you're required to wear safety glasses at all times. There's a list of PPE requirements. That's personal protective equipment, just to make sure that you're safe. And another safety, hazard is, the machines themselves. Even if you're wearing safety glasses, if you don't know how to use it properly, you can certainly hurt yourself. So in order to, use these machines on your own, you'll need to receive training first, which we typically offer. Every week you can get trained on different machines, learn how to use them. Because of COVID, we've had to limit that amount. So you can actually just walk in, and if you have a project that needs one of these machines, one of our student workers will assist you in your project and help you learn how to use the machine along the way. So yeah, with that, I think, Butter, you can give a quick tour around of the machines we got.
Sounds good. So as you enter on the fourth floor on the right, you'll see a hardware section. So the idea is that we have a lot of different screws, nuts, bolts, rivets, stuff like that available. So if your project requires a few nuts and bolts, you can use this resource. It really helps cut down time on, like, if you want to get like a quarter 20 bolts or something like that, you don't have to run all the way to the hardware store. You can just get it from here. So just a convenience function that we have that really helps out. On the left here, we have some manual metalworking tools. So we have hydraulic presses, rollers, We have some punch presses and stuff like that. So this is mostly to work with like either bending pipes or sheet metal, like shearing sheet metal or punching a holes or something like that in sheet metal. And I believe you can also set bearings with the press if you want. Right here we have the Lincoln Electric Welding Studio. So we'll head inside to give you a quick peek. Turn on the light. So you can see the welding studio is fully featured, like a lot of the variety of welders. So we have MIG, TIG, and stick welding. The good thing about this welding studio is, first of all, it has all of the necessary kind of jigs and fixtures you would need for welding, and all of the like the hand tools. So like you have a very rigid welding table with a lot of the fixturing jigs. So like you know, different types of clamps, C-clamps, hammers, stuff like that. We also have angle grinders. Oh, sorry. I don't. Okay, so we have angle grinders, we have hand tools in these drawers, wire brushes, stuff like that. Another good thing is that we also, you know, safety is one of our most priorities here at ThinkBox, and that means that with welding fumes are a big concern, especially when you're welding indoors. So we have full ventilation system, so they will exhaust it, filter it, and you know, it makes it much safer and enjoyable to weld. I personally welded in this space, and it's a very good experience. We have some very professional staff as well who are professional welders, so they can help you with your projects and help you help you learn welding. So very good resource indeed. Move on to the wood shop. The lights are off. Good job. There we go. So as you can see, our wood shop is jam-packed with a variety of tools. So any tool that you can think of that you would need to work on woodworking, you know, projects, we will have here. So starting from the left, we'll just quickly go through what we have. So we have a table router to route out bevels, edges, chamfers on like your pieces of wood or plywood. We have a 4-foot by 8-foot shop pot machine. This is a CNC wood machine. It can cut you know, a computer guided pattern on plywood and wood. So you can see something like this. You know, this engraving was done using a CNC machine. Going on, we also have a wood lathe machine. So we'll show you some of the projects that are made with this, but it can turn pieces of wood. So you can make like bowling pins or like you know, rolling pins, for example, for you know, rolling dough and stuff like that, that you can do on this machine. We have a table saw. It's a pretty standard affair. You know, we have a very high quality saw stop, which is a very safe table saw because it has like a skin detection system. So if you can't hurt yourself with it because the blade has automatic retraction. So if you accidentally touch the blade, it'll retract. So it's a very safe to use table saw. We also have a different types of surface planer. So this is like a top manual feed surface planer. Well, this is an automatic feed surface planer. We also have an automatic feed surface sander. And you can see this is kind of an example of one of the projects that was built in this workshop. Is a very heavy duty workbench. As you can see, like it's very beefy and it has very solid, rigid legs. So this is like kind of a good first woodworking project because you always need like a good working table. And I believe they've built in this is also like type of a clamp that they've built into it to hold down pieces of wood while you like plane it or sand it and stuff like that. So this is a good example of stuff of like a project you can build in this space. We also have drill press. We have a drum sander, a massive disc sander. And then we have finish hand sanders. So we have orbital sanders and detailed sanders. We have a miter saw. As you can see, it can cut miters. We also have a panel saw. The panel saw is used to cut down bigger stock of 4 foot by 8 foot, like, you know, full sheets of plywood or something like that, to smaller, more manageable pieces. And then after that, you can take it on the table saw. You know, it's a good for quick and rough cuts. And then we also have a bandsaw for like finer detailed manual cuts. So now we'll move on to the metal shop. You can see as we walk towards the metal shop, these are some of the projects. We'll come back to those. We also have a tool pickup here because of COVID. We do tool pickups. So you can see this is our metal shop. It is fully packed with a variety of very good quality equipment that you can use. So you can see some one of our staff working as well. So we'll do a quick, just like a quick roundup of all of the machines that we have. There are a lot of them. Like I said, you can find the details of these on our website about the make and model and capabilities and the most recent policies with these machines, especially when it comes to COVID. So we have a horizontal bandsaw right here. We have a drum disc sander. We have a belt sander. We have different varieties of grinders for grinding and polishing metal. So you can see some of these are for like cleaning, more finer deburring work. Some of them are for like very coarse grinding. You can see here we have a line of milling lathe machines. So these are jet lathe machines, and they have digital readout system, which means that you can do very precise lathe work. I believe they go down to like 1 thou, which is 1,000th of an inch. So that's something very precise. These are some of the sheet metal, machines, so it's like for rolling and for bending sheet metal. And then moving here, we have some punch hydraulic presses for cutting. We have a big drill press. We also have a metal bandsaw. And then here we have 4 jet milling machines. So these are manual milling machines, but they also have a digital readout. So again, what that means is that you can make very accurate parts with these. These machines are used for our mechanical engineering classes. So the EMA 160 class, which is like our advanced, which is our mechanical manufacturing class essentially. So if you're coming at CASE as a mechanical engineer, you will learn how to use all of these machines and make a variety of cool projects on these machines. And then over here we have some drill presses. These are just to bore drill holes in metal. Very high power, so they can drill into a lot of thick and hard materials. So they're good tool. We also have a surface planer, so if you want to plane surfaces. And then over here we have our water jet machine. So right now you can see it's actively being used. I apologize if it is loud. I'll move away a little. The idea with the water jet machine is that it uses a high pressure stream of water mixed in with a fine abrasive sand, like powder, to cut through a variety of materials, including metal, stone, glass, so on, even wood, plastic, so on and so forth. You can see some of these parts that have been cut here. These are almost like 2 inches thick, but they have been cut using this water jet. So you can cut something, as thick as, for example, 2 inches. I'm sure the exact specifications you can find on the website. But you can cut a variety of parts in a very clean way. So you can see some of these parts that have been cut.
I think Badar cut out there for a second up by the water jet room. Might have lost service there while it's going to redo that. Hey, Butter.
Yep.
I think your video cut out just for a second. If you could just kind of pick up where you left off on the water jet, that'd be great.
Okay, my bad. I think this was a problem last time as well. There probably is like a lack of Wi-Fi service. I'll stay on a little bit of a distance so I can stay in the reception zone. But you can see that is the water jet. The water jet is essentially a machine that that does computer guided cuts in a variety of materials, including metal, wood, plastic, stone, so on and so forth. The idea with the water jet is that it uses a very fine stream, like high pressure jet of water mixed in with fine abrasive sand to cut through those materials. And you can see it is actively being used to cut out something, I believe it's in metal. But yeah, so that's the water jet. So here we have some milling machines. I believe this is a new addition. These are more staff-oriented machines, but if you do have a requirement for a project or something that requires a metal-based fully automatic milling machine, you can definitely reach out and see what type of service can be offered. And over here we have some sheet metal machines. So we have a bend and a brake, and a shear. So you can shear material, or you can bend it at various angles as you desire. So now we'll move on to talking a little bit more about the projects. So we'll go through there, as you'll be able to notice, there are a lot of projects here. So if we check on time, I think we're good on time. So we can definitely talk about some of these projects. So if you start on the most bottom shelf, you'll see there are different variety of woodworking projects here. So we have a cutting board, wooden cutting board. So you can see it has some cool, interesting patterns in it. This is a good project for somebody who's starting out woodworking because it's something functional. This you can build essentially using scrap wood, because it only requires small pieces of wood. So you'll notice different types of wood are just glued together and then cut on the miter saw, or you can cut them on the CNC router, and then sand them, finish them to get something like that. Make for a very interesting, present for a parent or something like that. But yeah, that's a good functional project that you can make at ThinkBox. As I mentioned, the wood lathe machine, we have some projects with that. This bowling pin was turned on the lathe machine. The idea is that you turn it along its longitudinal axis, and then you use a blade or like a cutting implement to kind of route out this shape manually. So that's something. As I mentioned, it's a rolling pin, so that was also made on the milling machine, on the lathe machine. Sorry. Some of those cups were also made on the lathe machine. You might have seen that, a cup like that on YouTube. Some of those videos have gained a lot of popularity. It's a resin encased, pencils encased in resin that have been turned into like a pencil cup. So something like that is something you can definitely make. And then some other examples of woodworking projects are like you can do picture frames. So there are complete step-by-step instructions on how to do picture frames. Again, we have all the tools necessary for that in our wood shop. You can also make cases for small tools and stuff like that. So you can see that's like a small, it's similar to a jewelry case, but that's actually for I believe that's a tap. So it's used to make it's a small tool. So if you have a small tool that you want to make a custom case for, that's something you can do. I believe that was done on the CNC router, so the wood CNC router. So you can definitely do something like that. And then if you look up, you can see a basic toolbox that was built, or like a tool. You can like a tool case type of thing. Not exactly a toolbox, but to carry your tools around. And then this, you can see the skateboard. That was also a project done here. So that requires a little bit more advanced knowledge of how to press or bend wood into a shape, but you can also use the tools available here to make your own custom skateboard. And you can put you can even engrave it and stuff like that. The real beauty comes when you combine the fourth floor and the third floor machines. So for example, you can engrave your own custom pattern on it. As you'll notice on this cutting board, there's ThinkBox written on the side that's engraved using the laser cutters. So that's definitely something that you can do. If you talk about some of the more metal shop related projects, and you'll see this is a hammer. This is essentially the hammer that is designed in one of the classes. So if you take mechanical engineering, you'll take the mechanical engineering class, like the 160 class that I was mentioning before. And in that class, you learn how to design. And then make this hammer. So you'll learn how to use the milling machine and the lathe machines and all of the finishing steps to finish, to make this hammer completely from scratch. And then you get to take it home. So it's a cool keepsake, for and then it's like a very good hammer. So you can definitely make something like that. And then we have a variety of different cool projects. So you can see there's a ball maze. It has crew written on the side. If I can zoom in on it. Yep. So that was made on the CNC milling machine. That's also something you can make. This puzzle was also made on the CNC milling machine. You can see some of these clamps. You can buy these clamps, but you can also make them. So that's a good example of something, you know, if you want to experiment with metal metal fabrication, it's a good project to get your hands dirty. With most of these projects, the good thing is that since our staff here has made them, they have you know, they have good knowledge of what the challenges would be, what materials would be required, and what do the projects entail. So if you come and if any of these projects inspire you and you're like, you want to replicate these with, like yourself, they'll be able to help you a lot in you know, what materials you need, like what trainings you need, how to get started, the design files, so on and so forth. So if you don't have an idea of what you want to make, you can pick out from any of these things and, you know, come in and say that I want to make this, and they can help you get started. If you do have your own idea or like a variation on any of these ideas as well, that's also highly welcome. And we will work with whatever idea you have and help you in the best way possible. You can also see in the back, there are some water jet pieces. So that red one is water jet. And then that pink box stencil is also water jet. So, you know, you can water jet some interesting designs, and that too in metal. So it makes for quite an interesting piece. So yeah, do we have any questions that we can field at this point, or?
Yeah, we do have a question. Milani asks, how old do you have to be to use ThinkBox?
That's a good question. So I think that is something Ricky would be able to better answer in the chat of like what our exact policy is. But I believe that like K-12 students are welcomed. I think until a certain age, we do need like a parent or a guardian to be present to you know, look over the kids and work with them. And some of those machines, like on this floor, do have a little bit more of an age requirement. Although the third floor is a little bit more flexible because the machines there are much more safer and like forgiving. So it varies a little bit on like which floor you're trying to work on. But I believe that like we do welcome kids. Kids come in, like I believe like we've had kids as little as like, you know, 4 or 5 years old, you know, come in with their parents and like their parents guiding them to like make something. So kids are always welcome. In terms of like, we do generally ask like if they're, you know, coming, the parents do accompany them and stuff like that, just to ensure their safety. But we always welcome you know, kids and the younger lot. But it is a little bit dependent on the machine usage, the project, and the floor. But we try to do our best to, you know, be as much helpful as we can, especially if kids have any ideas that they want to implement. We can definitely help them get to that.
Yeah, that's a great question. If anybody else has other questions, you can go ahead and throw those in the chat. If not, Ricky, I believe you have the whole hour, right? We want to go till 12?
To 11:45.
Oh, okay, that's what I thought. Okay, so then, yeah, I mean, in the last 5 minutes here, Butter, do you want to go to the 5th floor, or do we wrap
good. I think I would want to go to the 5th floor.
Okay, sweet. So I'll introduce that if you want to head up there.
Sounds good.
So anyway, we got a special treat for you guys today. We're going to take you all up to the 5th floor, show you around a bit. Butter's going to do a quick speed run of all the activities we got going on up there. 5th floor is our project space where a lot of the design teams on campus, the engineering competition teams on campus, like Crew Baja, which I'm the captain of, we have all of our project spaces up there where we create different projects, different vehicles. We have a NASA robotics team, which creates, you know, robots that are supposed to go to the moon. We have a rocket team, which creates the rockets to launch them. We have a design, build, fly team, which creates all types of airplanes and drones and things like that. Then, of course, we have the Baja team, where we build a single-seater off-road vehicle and race it across the country. So there's certainly a lot of stuff, a lot of really interesting things going on here on the 4th floor. So yeah, you can see there on Butter's screen, that is the Baja Bay, as we call it. where we have all of our vehicles and tooling set up there. So you can see that we build a single seat off-road vehicle that we get to race across the country. So that's a really fun time, and you learn a ton doing that. So Milani has another great question, Butter. She asks, are there any resources for people who want to take their product to market?
Yes, that is a very good question. Yes, that is we do definitely have resources. So we didn't talk too much about that because those are resources that are affiliated on the 6th floor, which is like our business-oriented floor. But you can definitely, and I personally don't have too much knowledge of what exact activities and programs that they're running, because it varies from time to time. COVID, I'm sure, has changed a little bit of things, but we do have some of those resources. So if like mentorship, guidance, help, like getting seed funding, venture capital, like how to manage a startup and stuff like that. We do have programs that from time to time do, like take cohorts and guide them through that process. So if you do have like detailed question of what programs do we currently offer, I would recommend emailing like the thinkbox@case.edu, and somebody will get back to you of like at this point what is the exact help and guidance we can offer you in that regard. But yes, we do do that, and we are trying to help local startups and people or students, community members take their product to market, because that's the whole idea here. Like it's starting from an idea and going all the way to like a finished product into the market. So we are trying to help as much as possible make that happen.
Yeah, so there's certainly a lot of successful startups that have launched out of ThinkBox. You can find some of those success stories on our website. But yeah, essentially we like to be an innovation center. So we help everybody from prototype to development to launching their business. You can see here as Butter walks around, we have the design, build, fly team and the rocket team base. Where they build a lot of aerial vehicles, super cool club, and they do a lot of really interesting competitions. So, if you're a student on campus, you're welcome to join any of these clubs or teams, and a lot of the work that you do will be here in ThinkBox. So you can see there that's a robot designed to drive on lunar soil and collect samples and things like that. So the robotics is another really cool club on campus. And most of what all these design teams do is all supported by ThinkBox resources and ThinkBox machines. So a lot of these, vehicles, like the Baja vehicle, are made essentially completely in-house at ThinkBox from scratch. So it's really impressive what a lot of these student teams can do. Yeah, at ThinkBox, we're really proud to be home to all these, design teams and other project spaces. You can see there on the project carts, if you need a long-term storage for your project, you can sign up for one of these carts, which allows you to store your project in a secure location at ThinkBox. So if you ever need to, come back, in further days, you can store your materials there. So yeah, that about wraps up our time for today. Does anybody have any other questions about ThinkBox in general or CASE in general, or anything about what we covered today? Awesome. Sweet. Well, yeah, thanks for coming, guys.
Sounds good.
Thank you.
Thank you, everybody. Have a great day.